What we're talking about here is multivariate analysis. Step 6. And this will answer our research questions, right? But for now, the first research question. Okay, so break it down. Multi means many. Var meaning variable. So it's an analysis between multiple variables, many predictors, right? Several covariate independent variables upon one dependent variable, right? So now consider this. Consider when we did bivariate analysis, we used 4 separate bivariate tests, right, to relate each predictor to the dependent variable. However, here in multivariate analysis, we'll be doing one test, okay, one test, specifically regression, where we regress all the predictor variables, all 4, upon the dependent variable all at the same time. So it's one test. And it's going to answer the big question, right? So number one, in the context of the full model, right, when all the joint effects of all the predictors are observed, which ones are still significantly related to the dependent variable? Because often in regression, you know, if you have a bunch of predictors that are significant, but when you test them at the same time in regression, some of them become no longer significant, right? So that's what we want to know. Who stays significant with all the joint impact going on at the same time? And 2, right, which is the strongest? So if 2 or 3 remain statistically significant, which one of those are the strongest predictor of the dependent variable? So how many regression tests do we need for multivariate analysis? We'll consider 3. Linear regression, 1, 2 binary logistic regression, and 3 multinomial logistic regression, which is not reviewed in this class, okay? Now, a little asterisk, this is when we have a cross-sectional analysis. That is when the dependent variable is measured, you know, at one time point. If it was longitudinal, and we had, you know, a measurement of class attendance, you know, month 1, month 2, month 3, we would use a different multivariate test. But we have it one measurement, so these are our multivariate tools. So again, we look at the structure, right? Remember, the structure is going to guide us on what test we need. So 1, class attendance in a continuous form, right? That would take a continuous dependent variable, right? So 2, categorical of 2 categories, such as class attendance, you know, grade 3 days a week or greater, right? Or you know, the second category, less than 3 days a week, 2 categories. Or, you know, a third that might have 3 or more categories, such as attends class, you know, yes, no, sometimes. So we break these down into a multivariate test case where we have the dependent variable on the left and the corresponding test to use on the right, right? So if it's continuous, linear regression, categorical of 2 categories, binary logistic, categorical with 3 or more categories, multinomial logistic. Right, so we just plug everything in here, and we see here, right, we're using class attendance measured on a continuous basis of 1 to 7 days. So linear regression is the way to go. So that's what we're going to do. And of course, there's a whole lot of test assumptions for linear regression, right? Most important thing to know is that these exist and you need to do them. You can always look up how to do them, you know, fairly easily. But you know, you can't look them up if you don't know you need to do them. So we have listed here 1, normal distribution, 2, multicollinearity, 3, homoscedasticity, 4, linearity, and 5, no undue influence of outlier scores. Right? So those must be checked before the actual regression is done. Now remember, we are looking at a linear regression, so we're looking at a linear relationship. Right? So What does that mean exactly? So suppose we have an X and the Y axis, and on the bottom we have class attendance from 1 to 7, and then on the left, going up, we have class enjoyment. Well, we could see, right, the little dot is a score, right? One resident score, on each, right? So you can see the first little dot is 1 and 1. So if someone enjoys class out of 1, right, 5 is the highest enjoyment, right? So they enjoy it out of 1, the least amount, they attend class once a week, right? The corresponding 1 on the bottom. Then you'll see the dots around 2. If they enjoy class a little more, right, the dots for enjoyment are on 2, then, the dots are at 2 and 3 days a week. And then it goes up until the highest level of enjoyment is 5, and those dots correspond to class attendance at the 6 and 7 level. And you'll notice in this pattern, the dots form like a diagonal line. That's the line in linear regression. That's what linear regression is looking at. Okay, now, important point to remember, if you're going to do regression, right, any type of regression, you need to have the variables, dummy coded and choose a reference group. So if we're using a categorical predictor with more than 2 categories, right, it has to be dummy coded where each category becomes a yes/no variable. If you already have a categorical 2-category variable, like class assignment morning or evening, you don't have to dummy code it because it's already 2 categories. But you have to make each category here into a 2-category variable. Okay, so let me show you what I mean. So that means that the dummy coding turns the single categorical variable into several yes/no variables. So if we're looking at doctor prescription, status, did he prescribe or she prescribe class? We would, you could answer no, the doctor did not, the doctor recommended it, or yes, right? So that's our original variable with 3 response options. If we were to dummy code, each response option becomes its own variable. So variable 1 would be doctor prescription status no, yes, no. That's one variable. The second one, doctor prescription status recommended, yes, no. And then the third variable would be doctor prescription status yes. They prescribe meditation classes. Now you'll see in the regression, in the statistics, we're going to leave out one group, and that's going to be. Now the other thing to remember is the recode function in SPSS, that's actually the same function we used to recode the dependent variable into, attending class 3 days or more, or attending class less than 3 days. That's the recode function. That's the same way we would dichotomize these. So we won't be going over it again, but in the written materials, there's a detailed instruction to how to dummy code this particular variable, doctor prescription status, into each of these 3 dummy coded variables. Speaking of which, how do you do linear regression in SPSS? 4 steps listed here. We will go and actually implement those right now. All right, so if we go back to our old friend SPSS, right, analyze and regression, and then it's right here, linear. And then we put class attendance in the continuous form and under dependent. And then we put our predictor, so age, it's a covariate. Then, now don't forget, we're going to leave out the reference group, so we make no the reference group. So people that were not prescribed classes by their doctor. So the findings will be in reference to the reference group. So we put the 2 other dummy coded, right? So there's, yes, recommended, and then yes, yes, right? So yes, the people who were prescribed meditation classes by their doctor. Then we put in class enjoyment. And finally, class assignment, the independent variable. Right? Now, it's certainly paste-worthy, so you could paste it like we did the rest. Right? There we go. And in such case, you highlight it and click Run. And there we go. Here we go. So we have the model summary, the ANOVA. Right? So let's go look at these on the slides. So we have that done. Now, the first box you want to pay attention to at the top of the output is labeled ANOVA. Okay, so the first thing we're looking at is the statistical significance of the overall model. So if the overall model is not statistically significant, right, none of the rest of it's believable. So if it's not 0.05 or below, we don't look at anything else. But we see here it's 0.000, way below 0.05. So the overall model is statistically significant. After that, right, the next box underneath, the coefficients box, the final column is labeled SIG. Right? Here it's highlighted in yellow. That's looking at the statistical significant relationships between the predictor and the dependent variable. Right? So we want to know one-on-one, you know, in the context of the full model, if the predictor predicts significantly the dependent variable. Now you see age, right, not constant, that's the first, but age is the first predictor. Going across that line, you see the significance is 0.929, which is way above 0.05. So that's what makes it interesting, because now in the context of the full model, age is not significantly related to class attendance anymore like it was at the bivariate level. So when all these variables are considered, age is no longer a significant predictor of class attendance, but you don't know that unless you go to the multivariate level. Right? At the bivariate level, you might think it's just as important as everything else, but then at the multivariate level we see it's actually the variance is explained by the other variables. That's actually what's going on. So there's a certain amount of variance where age predicts attendance, but the other variables have explained, you know, that variance. So then next we see doctor prescribed, class recommended. And remember, that's in reference to doctor didn't prescribe meditation class. The significance is above 0.05 at 0.166. So that's not statistically significant. Now the bottom three predictors are significantly related to the outcome, class attendance. First one being that the doctor prescribed class yes is significant. So that's in reference to the reference group doctor did not prescribe class. No. So what we would say is in reference to, you know, residents whose doctors, you know, did not prescribe the class, residents whose doctors did, yes, prescribe class were significantly more likely, you know, to attend classes. Right? We also see class enjoyment, right? So also notice that there's no minus, meaning it's a positive relationship. And so that means as class enjoyment goes up, 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 right? Class attendance at the same time goes up, 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 right? Positive relationship. Now the same with class assignment. We see class assignment also has a statistically significant relationship with class attendance. All right. Now, the next thing we want to look at, right, is the directionality, which we just alluded to, right? So we could see the bottom three, right, the statistically significant predictors all do not have a minus, right? We don't consider age because that's not significant, right? It has a minus, but we don't consider it because it's not 0.05 or below. So we see all positive relationships, right? So like I said, as enjoyment goes up, attendance goes up, right? Next, now the standardized coefficient beta, beta coefficient, identifies the strongest predictor of the dependent variable in the regression model. So the highest one is the strongest predictor. We could see class assignment at 0.41 is the highest, right? It's the only one, above 0.4. So that's the strongest predictor of class attendance in the model. Right? So it's sort of a magnitude. Now, a traditional effect size for the regression model is the R-squared. So the R-squared is under, I believe it's the first box in the regression output, and it tells you the degree of variance. Right? So attending class varies from 0 to 7. And what we're trying to explain is what explains people going to 1 class, 2 classes, 3 classes, so there's variance in the outcome. So how much of that variance is explained by this bunch of variables? So the variables have a joint effect, and explaining class attendance, how much does it explain? So that's what the R-squared presents, right? 0.4, 40%. So we would say that our predictors explain 40% of the variance in class attendance, which is it's a lot of variance, right? So if you had to explain what predicts you doing something, right, there's 100%, right? So if the alarm clock rings and that's what gets you up, that might be 100% of the variance, what makes you get up, right? So 40% in anything is a really high degree of the variance explained. Okay, now the linear regression doesn't produce an effect size, for the predictor variables. So we can go and do an ANCOVA, which again is based on variance around the means and all. It's very similar to linear regression. These are the steps, and that will give us a PES, right? An effect size partially A squared. So we'll do that really fast in SPSS. So we go to Analyze, General Linear Model, Univariate, because that's one dependent variable, uni. So we can put class attendance in the dependent, and then put in the covariates, right? Age, right? Class enjoyment, and then also doctor prescription status. Put it as the original kind of more of a continuous, right? So the covariates should be all continuous. So doctor prescription is the full one, right? You could say it goes from no, recommend, yes, so it's almost a continuous of, how much they are prescribed. Okay, and then we put class assignment in the fixed factor. We go to options. We click descriptive estimates of effect size, continue, and then we could paste it or click OK. So just for variety, we'll click OK. So then right here is our output, and you can see the partially A squared effect size, right? The biggest one. And so again, the 3 bottoms are statistically significant, and the biggest one is class assigned, which is 0.22, which is a large effect size. So we would say, right, so we take it back to here, right? So we would say that class assignment has a large effect size on the dependent variable. All right. So that's our magnitude. So the multivariate model indicated that when we control for age, doctor prescription, class enjoyment, that class assignments related to class attendance where those assigned to evening class attended significantly more days per week relative to those assigned to morning class, at a statistically significant level with large effect size. So that's the encapsulation, the whole story, the result of that analysis. Right? So let's all think about 1b, right? That other dependent variable where it's dichotomized, right? And consider what bivariate tests we might use to examine that. So step 5, bivariate analysis. Right, there's our map. Right? And then recall the bottom, we said we would review categorical on the bivariate test key, which is the chi-square test. Right? Specifically, we want to look at the categorical variable class assignment, mornings, evenings, in relation to the categorical variable attended class 3 or more days or less than 3 days. Right? So now the chi-square has assumptions too. A lot of people don't know that because it's non-parametric, so a lot of people assume it doesn't, but these are a couple. So table larger than 2 by 2, no more than 20% of expected counts. We'll see that, are less than 5, and individual counts are 1 or greater. And then 2, if you have a 2 by 2 table, they'd like, approximately 10 people in each cell. So that's 4 cells if it's 2 by 2. So that's 40 people. So in a qualitative study, that's a good amount of people to have, right? So if you have less, so if you're doing qualitative, you have less than that amount, you could consider the Fisher exact test, which is better suited for a smaller amount of study participants. So the chi-square and SPSS, here are our directions, and we will actually go do that now. So here we go. So analyze, descriptive statistics. Then there's a couple of ways to do it. And then cross tabs. Then so it's good to put the dependent variable in the column. So that's attended class at least 3 days. And the predictor class assignment, we could put in the row. Then we click statistics, click chi-square, and then the effect size is defined. Kramer's looking at that, but that's what you would click. Continue, and then the cells under percentages, we click row, continue, then we paste it, or click OK. And there is our output, and let's look at it on our slide. So, bunch of numbers, what do we look at? There you go. All right. So the most interesting thing is well, first you see if it's statistically significant. So we can see on the second box, on the line that says Pearson's chi-square, it's below 0.05, indicating a statistically significant relationship. Then observe the column yes. So attended class, equal or more than 3 days, yes. Then we see the percentage for morning and evening class assignment. So in the morning, if we go over under yes, 56% assigned class in the morning attended class 3 days or more. But if we look below in the evening, 86% of residents assigned class in the evening attended 3 or more classes. So that's why it's statistically significant. There's a big difference in those proportions. Right, so we're not gonna go over all the bivariate tests, for dependent variable 1b, where it's dichotomized, but they're all statistically significant because we did the B-more-T test and we've gone over that already. So they're all significantly related to the dependent variable. So then what do we want to do next? Consider the multivariate analysis, of course, right? So we want to see of all these significant predictors, how do they relate to the dependent variable, as a joint effect? So the study map says, step 6, we're examining multivariate analysis. Again, we referred to the multivariate test key. And we see now we're right in the center. We have a categorical dependent variable, 3 days or more, yes, no. So we use binary logistic regression. So we're looking for, is there a significant relationship between the categorical dependent variable, yes, no, 3 days or more, the covariates independent variable. Now the test assumption, which I guess makes it more attractive many times, there's less test assumptions for the binary logistic regression, but you do have to look at multicollinearity. All right, so specifically, are residents assigned to classes in the morning, right, significantly more likely to attend at least 3 classes per week, yes, no, relative to those that are assigned to evening classes? Right, and here's our final statistical test for the day, binary logistic regression. Okay, so we'll do this one, right, in SPSS. And so back to analyze, back to regression. And this time we go to binary logistic. We put the dichotomized dependent variable independent, so more than 3 days, less than 3 days. Then we put our covariates, and again, age, right, just the 2. We leave out prescribed no. We put in doctor prescribed, recommended, and yes. We put in class enjoyment. And finally, we put in class assignment. All right, class assignment. Then we go to options, click that, and then click over here, CI for the exponent B, exponent beta. That's what the XPB means. 95%, those are the 95% confidence intervals that are regularly reported. Then we say OK. Then we have our output. Right, here we go. And we also have it on slides. There's a few extra tables in there we're not going to refer to, but on the slides we'll go over the most important. All right, so we've gone over this. Now, the first thing to look at, there's one table marked omnibus test of model coefficients, right? So this tells us is that the whole model is statistically significant, right? Just like the linear regression. If it is, we go on. If it's not, we stop. We see it's way below 0.05 at 0.0000, so we go on. Just like linear regression, now we look at the statistical significance of the predictors on the dependent variable. Now, many times you get conflicting findings whereas continuous, there are certain predictors significantly related. Then when it's dichotomized, different predictors are significantly related. But here, it's all the same. You could see the bottom 3 predictors, right? Diagnosis, yes. Enjoy class and class assignment are still the statistically significant predictors of the dependent variable. Look at the beta, so we can see directionality. Right? They're all positive, just like before, positively related. Now we look at, this is the effect size. So the odds ratio is the actual effect size for the test. So the biggest odds ratio is the biggest effect size in predicting the dependent variable attending classes at 3 or more days a week. And we could see the biggest odds ratio is under class assignment. It's bolded, it's 6.44. So what we would say is that people assigned to evening classes are almost 6.5 times more likely, right? 6.5 being 6.5, 6.5 times more likely to attend class 3 or more days a week, relative to those assigned to morning classes. Right. Now, one thing to keep in mind is the enjoy class, when you read that odds ratio, you don't read it the same. It's a 1.744. That you can't say, more likely, less likely in the same manner with a continuous predictor, right? You can with the doctor prescription yes, right? That's 4.7, almost 5. So you would say in reference to the reference group. So people that were prescribed meditation classes by their doctor were almost 5 times more likely to attend classes 3 or more days a week relative to, or in reference to, people that were not assigned, right, or not prescribed classes by the doctor. All right, so the big take-home message here, again, when controlling for age, doctor prescription, class enjoyment, class assignment is related to class attendance where those assigned to evening classes are more likely, right, 6.44 times more likely, to attend class relative to those assigned to morning class at a statistically significant level with a large effect size. So this is our big accomplishment, what we've accomplished with all these numbers, okay? We use statistical analysis to identify significant influences on the dependent variable in bivariate analysis. 2, we use multivariate analysis to control for significant influences to covariate variables while noting the independent-dependent variable relationship of interest. So we've identified at the multivariate level that there's a statistically significant relationship between the covariate variables and independent variable, right? Now, what we want to remember here is, like, these are numbers, right? This is what it indicates, but that it's not definitive, as number 4 says. It's food for thought. These are what the numbers are telling us is the situation, right? But it doesn't mean it's absolutely what's going on. So in terms of the research questions, these are our answers, right? So research question 1A, is assigned class time the strongest predictor of the number of days attended class per week? Yes, right? So assigned class time is. Research question 1B, is assigned class time the strongest predictor of attending class at least 3 days per week? Yes, right? So we got 2 big yeses, right? So quantitative analysis has indicated the strongest predictor of class attendance is class assignment. So that's what the numbers are telling us. So in terms of they're wondering if all classes should be moved to the evening to encourage attendance, right? It looks like, yes, that should be done. But now we have to wonder, is that really the case? Right? It's a big decision. Is that really what should be done? In other words, we need to ask ourselves, are our quantitative findings like a mere illusion that is masking the true reality of the situation? So next week, we're going to apply qualitative methods to reveal if some unidentified factor is driving these findings. All right? So we're going to see if we've captured enough of the residents' perspective with this quantitative analysis to really answer the questions they want answered, right? Right? Or if this perspective would have been lost without the addition of a qualitative component. Okay, so thank you for attending, and we will cover all that next week.